Hello, I'm Nicholas Taubert, and this is my first tutorial video for game design. I chose to do 10 hours of junior programming for this video. The exact mission I chose was called Junior Programmer Create with Code 1, Programming Basics, and I completed 11 hours and 30 minutes out of the 14 total hours for that mission. The first section detailed how to install Unity and how to change versions in Unity. Unity is obviously installed as I have it currently open on the screen, and a new project can be created by clicking this new button, choosing the version, and then from here, a template can be chosen, such as 2D or 3D. A name can be given to the project. The location the project should be saved at on the system can be chosen here. And then finally, the user clicks create to create and open the new project. All right, so once we have this Unity editor open, the first thing that we did was went to Assets, Import Package, Custom Package, and from there we chose the package that contained all the assets that we used for this first project. Once in the project, we began to explore the different parts of the Unity interface to get to know how to maneuver it. This part on the left is the hierarchy. This is where we can select and view all of the game objects that are in the scene. This part on the right is the inspector. This is where we can actually view the details of the current game object, such as the location with the transform component, but also if it has more components, that's where we can see scripts. That's where we can see rigid bodies, which are like colliders. This bottom part is where we have our project window, which is where we can see like all the assets that we have in the scene, all the prefabs that we have in the scene. And in console, that's where this console view is right next to the project view. This is where we can see any errors, any debug.log calls, anything like that. And finally, in the center, there's this scene view, which is the visual editing interface for actually doing work in Unity as you're editing the game. This is just on the creator's side view. And then this is the game view right next to it. This is what the player will actually see while the game is running. So if we click this play button at the top, then we'll actually see in the game view like a example of what the game is going to look like when it's actually running. All these views are constantly used while creating games in Unity and can actually be changed, like the window layouts. They're changed by grabbing and moving wherever things would like to be brought to, and there's all sorts of places that each of these windows can be snapped to. And then up in this layout section in the top right, different default settings can be chosen, or once they're edited manually, a layout can actually be saved by clicking save layout right here, and then a new option would appear with that layout below where it was. I'll put it back to default because that's what I prefer. So inside of this scene editor, we can actually see where some of these windows become useful. For example, if we want to edit this truck right here, if we click on it, now it's highlighted and we can see its information in the scene editor. If we want to change its position, for example, there's a couple different ways we could do that. We could grab the arrows on the truck to move it. We can edit its position in the editor, such as if we want it to be at position x equals 2. We can also click on the vehicle in this in the hierarchy at the left of the screen to highlight it. And finally, if we made an edit that we didn't actually want to do, we can click Control Z to put it back to how it was. And there are several additional tools up at the top left, so that once the truck is highlighted, either in the hierarchy or in the scene, at the top left, we can click this rotate tool to rotate it manually, such as that. We can click the scale tool to scale it in any direction. If we hold control, it'll move in snapped increments. This next tool is the rectangular tool or rect tool, which can be used to size it accordingly, as you can see there. It's a little more useful in 2D games than 3D games because then there'd actually be a sprite that you're maneuvering such that way. And finally, this last one is just kind of a all-in-one. You can move it, scale it, rotate it, whatever you want to do. You can also use keyboard shortcuts to do this. E is your grab tool, which is just to maneuver the scene. W is your movement tool for the object that's actually currently highlighted. E is the rotate tool for that object. And R is the scale tool. T is that movement tool that's really only useful for 2D games. And Y is that all-in-one tool. This game object can also be renamed in the hierarchy by going up to the object in the hierarchy, right-clicking the object and clicking rename. Now to move around as the actual viewer in this scene view, if you right-click, that's how you can rotate in place, like I'm doing right here. You can hold right-click and press the WASD keys to move, just like you would in a video game, like if you were like the Oracle in Halo, or like in creative mode in Minecraft. That's how you maneuver. If you have an object that's highlighted, let's say we were all the way over here, and we can even find it in the inspector on the left side, or the hierarchy on the left side. Once it's actually chosen, we can press F to focus in on that object. We can press Alt and then press left click while holding Alt to revolve around. And we can do Alt right click to zoom in and out of the current object. Using all these tools, the first mission had us place this car at the front of the road and place an obstacle right in front of the car. And we placed a camera right behind the car, because the camera is what the player will actually be seeing through, as you can see in this bottom right area. That's what the player will actually see as the game is running, is what's through the camera. They won't be able to just fly around like we are here in the editor. After that, we actually started working with C# scripts. So to do that, down in the project window, we made a new scripts folder, and then we created a new C# script called player controller, as seen here. Now, when we first made it, it wasn't this complex. It just made the truck here move forward at a constant speed by going down to this update function, and we had a transform translate that just moved it forward every frame. So let me explain a bit better what that means. This update function is called every frame, which can vary based on how on the system that's running the game and based on how demanding the game itself is. But that's something like 60 a second usually. Further down the line, we actually ended up changing this because we wanted to actually have it respond to user input. We didn't want it to just shoot the truck forward at a crazy speed. So we eventually added this time.delta time so that it wouldn't just move more if there's faster if there's more frames. This time.delta time is going to be smaller the more times it's called and within a second. So that's going to keep the speed more regulated. And this horizontal and vertical input we actually got from the integrated Unity like controller manager. So as of right now, that's set to be for vertical, it's W and S, or the up and down arrow keys, and for horizontal, it's A and D, or the left and right arrow keys. And it's through that our truck can actually be controlled by the player. It's through that there's actual player input that matters to the game. And as we can see, forward and back does that vector call we saw. So it's adding a vector that's just pushing in the forward direction relative locally to the truck. And then the other function rotates the truck That one is this transform.rotate. And then again, it's a vector, but this time it's on the y-axis instead because you're rotating along that axis. Along the way, we also learned a lot of coding skills and programming skills. Like we learned about functions, such as start and update functions. We learned about variables. Up here, we learned about access modifiers like private. We learned about the data types. We learned about variable names and the different types of variables like floats. And we also learned how to do comments in our code to keep it clean and to make sure that we can keep track of what everything's doing. We also changed the color of our inspector while the game's running. That way, because if you make any edits while the game is running, it won't actually keep those edits. Once you go back, once you exit play mode, all those edits are going to return to how they were before you entered play mode originally for testing. We also learned how to copy objects in the hierarchy, such as these obstacles. We actually made one obstacle first by to create objects. If I didn't say it earlier, you go down in this assets folder and you find whatever object you'd like to add, and you actually click it and just drag it right into the scene. And then if that is a object that you want to copy, you can actually go up here, Control C and Control V, and it makes a copy of that object. You don't see it yet because it's actually right on top of the crate we made originally. But then if we pull it over, there it is. And to keep things clean, oh, and also if you click on an object and don't want it there anymore, you can click it and click delete, and now it's gone. You can also copy multiple objects at once by highlighting them all at once and copying them and pasting them, which we did to make this row of crates. And to keep things even prettier, you can make empty game objects. So when I click this obstacles game object, you see it's technically right here, but it doesn't really exist. It's because it's actually just a holder for all these crates to keep them all in one spot, kind of like a little folder. And finally, you'll notice that as the game is running, the camera automatically follows the player. We're not just watching the car zoom away. The reason for that is because on the camera, we actually have this follow player script attached, which every frame will move every frame. This is called we've run it in a late update instead of a normal update because otherwise it'll compete to try to go first with the script we have to move the truck, and that'll just cause like this weird jumpy effect. So we always want this one to go after the other one. Every frame we want this to go after moving the truck, but it'll update the position of the camera to always be set to where the truck is plus an offset, which is actually a vector, as you can see up here, that pushes it back and up a little bit so that you can actually see the truck. You're not just stuck inside of it. Finally, you'll notice that on all these obstacles, well, you don't see on the object there, but yeah, these obstacles, you'll see on the right side, there's a rigid body. And on the vehicle, there's a rigid body. The rigid body is used to give physics to the objects. So that's why if I drive this truck into the crate, you'll see the crate actually moves because they actually interact with one another. They won't just phase through one another like they would if they didn't have these colliders on them. And also these rigid bodies and colliders will give it gravity. So once it falls off the road, it just falls to its inevitable doom. Once we're done making that game, we actually moved on to a challenge. In this challenge, we were given a broken game. Well, broken meaning it had a lot of bugs in it. It didn't run how it was meant to. The plane was going backwards. It was going way too fast. It was automatically tilting in a direction. The camera was like in front of the plane. It wasn't following the plane, and the little propeller wasn't spinning. So the challenge was to actually fix all these bugs. And in that process, we had to diagnose the code, figure out what was going wrong. To make the plane fly slower, we had to add this time.delta time. because again, otherwise it was just like 60 times a second ish or more or less. It would push it forward by this speed constantly. But now with the time to delta time, I'd make it so it's consistent between each second, how far that plane would move in that amount of time. It was also originally going backwards because the vector that was assigned to it was not forward, it was back. The plane was also tilting automatically because it wasn't responding to user input. It wasn't getting this vertical input that get access. It was just kind of set to keep flying on its own. But so now it will respond to the player's input. It'll actually tilt up and down based on what the player is doing. The camera had to be given an offset so that it would actually not just be in front of the plane, but it would actually move to these coordinates, this 30 on the X and 10 on the Z. But also that wasn't enough because if the plane started flying away, then you wouldn't be able to see it anymore. So we had to also add this part of code to the bottom in this update function so that as the plane moved, it would constantly move to the plane's position plus that offset. Finally, the propellers didn't spin. They just kind of sat there, which is unrealistic. So I made a new script and attached it to the propeller that just makes this, which is the game object the script is attached to, rotate a little bit every frame. So the complete product looks like this. The propeller spinning, the plane actually moves in the direction that you tell it to. You can collide with the walls. You can give player input to move the plane to where you want it to move to. You can, oh man, I'm having a difficult time controlling this. You can still phase through the walls a bit because it's constantly pushing the plane forward. So you hit it hard enough, it'll let you, but if you don't hit it hard enough, it won't let you. And the controls are inverse, which is pretty typical for a flight game like the Banshees in Halo or like most other flight simulators. But yeah, the camera follows the plane all the way through. The whole game works. Next up was a lab, which had us design a project concept, not actually to like build all the way through, but just to like see, because there's a very scope creep is a very dangerous thing when it comes to game design. It's very easy to just keep throwing on things that you want to do because you want to make this awesome game. You want to throw on a ton of unique features, but it's really easy to become overwhelming, especially because we're used to playing and seeing like AAA title games that are developed by entire teams of people all spending hundreds of hours each on this project, which adds up to be thousands and thousands of hours, which obviously is not doable for anyone. But so I designed kind of the outline of a game just to kind of visualize it. The lesson gave a bit of different options as far as what kind of game we wanted to be, what we wanted to control. I decided to make one where you're a little raccoon that in a top-down game that can like move side to side to try to dodge like oncoming cats and cars. And you would try to touch, if you collided with these trash bins, you would have an integer that is like trash go up one, and then you can throw trash at cats to make them deactivate or destroy those game objects, but the cars would be immune to the trash, and you'd just see how long you could survive. Your lives would go down each time you collide with a cat or a car. And then this was probably the most beneficial aspect of it, was to actually design a timeline of what it would be like. So you would what would be what would be the objectives for the first week, keeping it realistic, something you could actually do in a week. What would be your objectives for the second week, third week, all the way down. And then there's also some stuff that said to kind of like stuff that isn't vital, things that your minimum viable project could go, your game could be playable without these things. We'd really prefer to have them if you have time. And then we had to develop a project sketch, something that in images, another person could look at this and figure out kind of what I'm going after. They can visualize the game to an extent. And so, like the project shows, the screen would be scrolling down. The player can move in every direction and could throw trash. Cats can damage the player but can be defeated with trash. Cars cannot be defeated with trash but still damage the player. And then trash can be collected by being touched so that it can be thrown. After that, I took this 15-minute quiz on Unity that it has as part of the track to move on to the next part. Next, we read through this um, tutorial that gave like an overview of project management, like designing a project, producing a project, the how going through the planning of that project, the importance of communication and other interpersonal skills to actually see a project's completion, as well as like realism and time estimates. Um, as far as like how publishing a project would go, tracking your expectations with that project, things like that. So the next project project that we started working on, this farmer that can move back and forth. And as you can see, there's actually animals that come down. But the first thing we did was we created this character, and this is actually the furthest I can move. It won't let me move any more to either side. We're about to look in the script to see how we do that. Then also, if I press the space bar, it launches these little food prefabs, and you'll notice if you look at the hierarchy on the left side, when the food prefab goes off the screen, it gets deleted automatically. And when these animals go off the screen, like the doe, that fox, now there's a moose, and now they go away. As they go off the screen, it'll get deleted. Finally, if I open up my console here, you can see that whenever contact is made with another animal, it'll actually throw a message in the log. So the first thing, we actually have a lot of scripts on this one to keep things all legible, to make sure everything has a very distinct purpose, and make sure everything's well commented. So this is the controller for the player, and you can see there's two main parts to this. First of all, the player, this is just the movement script for the player, how they can move left and right, but also it uses if statements, which you learned about in this section, to check if the player is trying to move past a certain range. If they're trying to move too far to the left or too far to the right, it'll stop them and just set it to stay where it was, stay at that range. Additionally, if the key press is detected on the space bar, then instantiate is called, which creates the given game object, which is projectile prefab, which is a variable all the way at the top here, which was assigned in the editor. If we go to the player, there's actually this projectile prefab assigned here that's the food pizza. And prefabs are really similar to they're a game object, but it's for if you want to have multiple copies of the same game object. So for example, if I was to create an empty game object right here, that this is a single one object. If I was to change something on this, if I was to add a component to it, it wouldn't actually, it's just that one object. Now, if I was to grab this object, and you can see right now it's gray, if I drag it into my project window, which technically it should be my prefabs folder, then now it's a prefab. Now it's blue. And now if I make any edits to it, to this prefab in the inspector or in the project window, then it'll also change that project or it'll change that game object in this project. I'm going to delete this because we don't actually need this right now. But so that's why, and so because we're making multiple copies of that food object, we have the food prefab right here, and we dragged and dropped it into the slot in this editor or in this inspector. And you also notice all the variables that are made public, such as speed, X range, can actually be changed in the editor right here in real time, which is really helpful for as you're playing. If you're not sure what speed you're going to want yet or which range you're going to want yet, you can edit it as the game's going and kind of see what fits best for the game you're trying to design. And then so instantiate, it calls that prefab at the position of this game object, which is the player, and it has the rotation of the prefab. Next is the move forward script. This is on all the animals and also on the food as well. Yes, because all of these objects move forward. It's a very simple script. It just says transformed at every update, it moves the speed forward times delta time, so it's a consistent amount of speed. The speed here is set to 40 as a float, but again, it can be edited in the inspector, which is done to give the different animals different speeds. Again, that'd be done right here. So like the moose has a speed of 15, the fox only has a speed of 5, and the doe is in the middle at 10. The destroy out of bounds script is more to make sure that the game stays running smoothly, because if you have a ton of game objects over time, that'll start to bog the computer down. So we put this on both the foods and the animals, and we just have it check. We put a top bound at 30 and a lower bound at -10, and it just checks if that object is past those boundaries, and if it is, then it deletes the game object. We have this game over debug.log that we saw earlier in the console where it pops up, because it's going through the lower bound, then it's an animal, not a food. And if the animal makes it all the way through the bottom, then that's when you would lose the game. That's what the objective we're trying to avoid. The spawn manager is probably the most interesting script, because it uses randomization to actually spawn animals at the top of the screen. The spawn range is how far left and right the animal should spawn. The spawn delay is how long, and like how long in time should the program wait before creating a new animal. Or the start delay. The start delay is before the first animal, and then after that, the spawn interval is in between each animal. We actually just have this function called once at the start called invoke repeating, which then after the 2-second delay, every 1.5 seconds, it'll find the function spawn random animal and call it, which is a function we wrote down here. It will choose an animal at random. There's 3 different animals, so we made an animal index in the spawn manager. This is an empty game object, but it has the script on it to spawn these animals. So we made an array of size 3, and we put all 3 different prefabs, all 3 different animal prefabs we're interested in, into that array. Yeah, so a random animal is chosen from that array. Then a vector 3 is assigned for the spawn position. Is going to be anywhere. It picks a random number between the negative and positive range x, which is 20. And then spawn range z is always going to be 20. But so it finds a different, so that decides where at the top of the screen as you're playing they should spawn, anywhere from all the way over here to the left to all the way over here at the right. Finally, at the end, it actually instantiates or creates that object. So it picks from the animal prefabs array the animal at that index, because it actually selects a random number up here, and then you use that number for the index. At the spawn position determined here, and then you grab the rotation of that prefab. This last script is pretty simple. It just detects collisions. If a collision, this is put on the food, the pizza. If it collides with an animal or any object, but the only thing it will collide with is animals, then you destroy the food itself and the animal that it collides with, this other. And that's the tutorial for this part of the junior programmer course. Thank you so much for watching, and have a good day.